Okay, here's part 3 of lesson 6.2. Last problem to do here. Again, it's a definite integral, so I'm going to be able to check this on my calculator at the end. Okay, first of all, it's a complicated integral. That's why I'm going to use substitution. On this one, I'm going to let you choose. What are you going to choose for you now? You go, well, how do I know what to choose? You want to choose for you something that when you take its derivative, du, you have most of that in there. So what do you want to pick for your u? Maybe look back at your other ones. Look back at the other ones. What might be a good one to choose for you? On this one, yeah, right there. That's what I'm going to pick for the u this time. It's going to be the x squared plus 1. Well, let's do the derivative then. What's the derivative of x squared? 2x. What's the derivative of 1, 0? Good. So du is going to be 2x dx. Now, what I'm going to do this. I'm going to rewrite this a little bit. Negative 1 to 3, and the x and the dx I'm going to put over here. Then I'm going to have what's left over, 1 over x squared plus 1. Now, take a look right here. I have to have 2x dx in the problem. I have to have 2 times x times dx. Well, I don't have that yet. I have to have it. I have to put it in there. Well, wait a second, though. That integral now is not equal to the one I started. What do I have to multiply the outside by? What times 2 gives me 1? Yeah, I got to multiply the outside by 1/2. There. Now, that integral is equal to the one I started with. Okay, let's start doing our substitution. Okay, what am I going to put in place of 2x dx? Yeah, du. Okay, du goes there. What am I going to put in place of x squared plus 1? Oh, 1 over u. I'm going to have the integral. I'm going to have 1/2. Now, don't do anything yet. We need new limits. We need new limits. Again, why do I have to get new limits? Because the negative 1 and the 3 were the limits when the variable was x. My variable now is u. I have to get new limits. Here we go. Hey, plug in the 3. Plug into 3 right into that equation. So it's going to be 3 squared plus 1. That's 10. That's my new upper limit. Okay. Plug the negative 1 into that equation right up here. Negative 1 squared plus 1. That's going to be 2. There it is. That's my new integral. Now look at that one. Look at the one in pink and compare it to the original one. It's a lot easier. That's the idea behind integrals by using substitution, by making the integral simpler. Okay, let's go ahead and do it. We got 1/2 bracket, okay, antiderivative. What's the antiderivative of 1 over u? What function, when we take its derivative, we get 1 over u? Oh, it's natural log of u, straight evaluation bar, 2 to 10. Oh my gosh, here we go. 1/2 bracket, natural log of the top one, 10, minus natural log of the bottom one. Let's get an answer way over here. We'll do it on the calc, okay? Here we go. We got 1/2 times natural log of 10, close it up, minus natural log of 2, close it up. Answer, 0.804. Let's go 0.805. There it is. That's our answer, 0.805. Now, can we check this one? Yes, we can. By doing what? By going back to the original equation, the original integral, I'm saying. The original integral, plug it in, and then do that and see if we get 0.805. Let's go ahead and do it, okay? Here we go. Let's go here, clear it out. We got math, we got Number 9, lower limit -1, upper limit is 3. Okay, now it was x divided by parenthesis. Make sure you use the parenthesis on the bottom. X squared plus 1. Gotta use the parenthesis. X squared plus 1. Good. And then outside, dx. There it is. That's the original. Hopefully we get 0.805. We checked our answer. We're looking good. A definite integral using substitution. Okay? And that's the end of lesson 6-2. Have a great day out there in Videoland.